All right, so we are continuing on with 3.7 called quadratic quandaries. And if you remember the context from before, we were kind of like, here, I'll show you. We were talking about, I think, Carlos and Clarita, right? And they are trying to raise money. And so they figure out that they can either do little like mascots on people's driveways or on their curb, and they're trying to make money in this way, right? And so what they've done is they came up with this kind of like equation that says $100 is how much, no, 100 was the number of driveways that they think that they can paint. And for every 10 driveways that they don't paint, it's because they raised the price of $20 for increments of 5, right? So they say it better here. So they're gonna sell 100 driveway mascots at a cost of $20, and they will sell 10 fewer mascots for each additional $5 that they charge. Remember, we talked about this a little bit, right? Where you're willing to buy something, but if the price goes up, less people are willing to pay that much for it. Does that make sense? So the twins estimate the cost of supplies is going to be $250. And then they want to make a profit of $2,000. So therefore this is where this equation comes in, right? And then we came up with how to solve the equation, right? And let me go back over here. So we solved this equation over here, right? So we said, oh, in order to do this, we have to set it equal to 0. And then we factored out a -50. And then we solved it and we said -50 isn't equal to 0. So he was useless. And we solved it to say x is equal to 5 or x is equal to 1. So x is equal to 1 means I'm going to raise the price by 1 increment of $5, right? And if I do that, then I can sell 90, like 90 people would get me, 90 people would still pay for their driveway to be painted, right? And the other answer was 5. So that means 5 times 5 is 25. So the other price that I'm going to charge is $45, right? But if I charge more, even less people will do it. So that's 50 people, or 50 driveways rather. And so that would be that, right? And so we got to, I think, like to number 4. And so now we're going to start here at number 5, right? So I'm going to work off this sheet. You guys have the same exact thing in front of you in Desmos, but I like working off of here. So it says, as you probably observed, the situation represented in problem 3 didn't just have one solution. This guy here, right? Since there are many different prices the twins can charge to collect more than $2,250 in revenue. Sometimes our questions lead to quadratic inequalities rather than quadratic equations. And so, like, let's say, I think I used this example last time, and I said, hey, you guys, I need you to bring $20 to class tomorrow because we're gonna, I don't know, buy supplies so that we can kind of come up with a plan to make money over the summer as well. So let's say that Robert brings $25, right? And some of you are like, yeah, but Ms. Johnson, you told him to bring $20. Now he brought $25. Am I not going to accept the $25? Yeah, of course I'm going to accept $25. That's just more money for us to use and invest, right? So same thing goes. If they get to 2,000, if they get to $2,250 in revenue, meaning money that they bring in, they're not going to be like, nope, I'm not going to, paint another driveway. Of course, they're going to paint more driveways. Yeah, they have to, buy more supplies probably, but they're not going to turn down making more money, right? More money is great. They said that they couldn't make any less than a certain price. So that's why it was greater than or equal to. So here's another quadratic inequality generated by Carlos and Clarita's business plans. So Carlos and Clarita wanted to design a logo that requires 48 inches squared of paint and that fits inside a rectangle that is 8 inches longer than it is wide. What are the possible dimensions of the rectangular logo? So some of you are like, wait, that's It's a lot of words, Miss Johnson. Like, what the heck are you talking about? Right. So let's take this a little bit at a time so that we can make sense. So Carlos and Clarita, they're going to design a logo that requires less than 48 inches squared of paint. So now think about it. The reason why they want to use less paint is because the more paint that they use, right? The more paint that they use, the more it's going to cost them to paint that driveway, right? So they're trying to like put a limit on how much paint that they use per logo, and that it fits inside a rectangle. Oh, they want me to draw a rectangle? Okay, I can draw a rectangle. So I'm going to just draw a rectangle. I don't know if this is proportional, but it's pretty good. Okay, and that fits inside a rectangle that is 8 inches longer than it is wide. 8 inches longer than it is wide. So here, I know that something is going to be 8 inches longer than it is wide. So if I say that this is how wide it is, X, because I don't know how wide it is, it's X. How long would I write this part to be? How long would I write this part to be? Oh, it doesn't say 8 inches? I'm sorry. Yeah, someone said that it doesn't say 8 inches on Desmo. So if you guys can fix that. Yeah, it would be X plus 8. Now, some of you do not like this writing. I know when you guys first start learning this back in like, say, 6th grade, writing an expression like X plus 8 is really weird, but this is exactly how, I mean, your brain thinks like this, right? Like, for example, I know that my sister is 6 years older than me. So if anybody says like, oh, how old's your sister? I take my age and then I just add 8 to it. And that's exactly what this says. Or I would add 6 to it because she's 6 years older, but so it's my age plus 6 years, right? So same thing goes here, the width plus 8. So is everybody comfortable with kind of like my drawing so far? Okay. Sorry, I'm just writing something down. Perfect. Okay, so then it says, what are the possible dimensions of the rectangular logo? What are the possible dimensions of the rectangular logo? Wait, okay, so wait, what? So I'm going to read it again, and I'm supposed to do something to write something so I can find an answer. So it says, Carlos and Clarita want to design a logo that requires less than 48 inches squared of paint. Oh, so what am I going to have to do to X and X plus 8? What am I going to have to do to X and X plus 8? Yeah. Why am I going to have to multiply them? Someone said multiply them. Yeah, because I'm looking for area. Miss Johnson, how did you know that you were looking for area? Because it said they want to design a logo that requires less than 48 inches squared. Squared, right? Inches squared means that I'm now covering this logo in tiny little Post-it. That's what I think about, right? Like imagine a Post-it that was an inch by an inch. It's a perfect little square. I'm going to cover this whole rectangle with tiny little Post-its, right? You see all my little rows, and there's not going to be any gaps. There's not going to be any overlaps. And I want to know, okay, how many Post-its did I use to cover this whole thing? So that's why I multiplied X times X plus 8. And they want it to be less than 48 inches squared. So what's the rest of my inequality going to say, guys? What's the rest of my inequality going to say? Yeah, less than 48. Okay. Now, why would I put less than 48? Because they said, that's what it says, less than 48. Less than 48. You guys all with me so far? Okay. So now I have to solve this thing. So I still haven't taught you really how to solve these inequalities. So I think right now, all I want you to do is kind of like think about what numbers would work for this. What numbers would work for this? So right now, this is just you. No, this one's a less than symbol, right? This one's a less than symbol. The reason why I know this one's a less than symbol is if you kind of like turn your head a little bit, it kind of looks like an L. See how it kind of looks like an L? That's less than, yeah. I know, I get them confused too. No big deal. Okay, so what I want you to do is I want you to kind of go through some numbers and figure out what numbers would make this true. Like what's an X that would make this true? Okay, what's an X that would make this true? So I'm going to have you work by yourself for just a second. Okay, so some of you came up with some pretty good X's and you just, I think some of you just plugged in a random number and it worked. Someone told me 4. So let's try 4. And then 4 plus 8 is 12. And so 4 times 12, wait, is 48, but 48 is not less than 48. So I understand why you chose 4, but do you want to change your answer? Okay, someone else chose 2. So let's try 2. And then this would be 2 plus 8, which is 10. Yeah, so 2 times 10 is 20. 20 is definitely less than 48. Yeah, okay, so that person revised his answer and said, okay, well, what about 3? Does 3 work, Miss Johnson? Okay, let's try. So 3 and then times 11, yeah, it would be 33, which is less than 48. So all of those even work. Even like because 48 is not less than 48, if you would have revised your answer to say like 3.5 or 3.9, it would have worked, right? So, but now I want to find all answers. So you guys came up with some of them. You said 2 works. You said 4 doesn't work. And you said 3 works. Okay. Nice. So someone said anything. Oh, I'm just going to snip it. Why am I writing this out? Jeez, Miss Johnson, technology. All right. Someone asked this in the chat. So anything less than 4, someone says, really like this. So I'm going to copy it into my notes. So yeah, anything less than 4 would have worked. Absolutely. So yes. And so notice that they didn't say anything less than or equal to 4. They strictly said less than, right? So now I actually want to like solve this problem and show you why this is true, right? So the first thing that I'm going to do, it's right here, number 6. So the first thing that I'm going to do is I'm going to pretend that this says equal to, okay? I'm going to pretend that that says equal to and solve the equation. So this says x parentheses x plus 8 is equal to 48. So if you remember from us solving quadratics over and over and over again, this side has to equal to what? What does this side have to equal to? Yeah, so make this side equal to 0, right? So that's going to be my first step. So I'm going to subtract 48 on both sides. So I get equals to 0, and now I'm happier, right? So at the same time, I'm going to multiply this guy out because I can't subtract it. So I get, let's see, I get x squared plus 8x, and then I get this minus 48. Okay, everybody comfortable with this idea? So far, so good. Some of you are like participating like crazy. That helps me so much. Yes. Okay, very good. So then now I want to solve this. Now you have options, right? You can factor, you can you can use a quadratic formula, you can complete the square, you can graph it. Which way is Miss Johnson going to use? Anybody know which way Miss Johnson is going to use? Yeah, Miss Johnson's going to use factor. I factor because it's the fastest. So I'm looking for 2 numbers that multiply to get to negative 48. But add to get to 0. So I'm looking for 2 numbers that multiply to get to 48, but then add to get to 8. So if you don't know, I'm going to help. So I take 48 and I write out all the factors. 1 times 48. 2, nice. Someone already had the answer. Awesome. 3 times 16. 4 times, oops, 12. 5, no, and 6 and 8, right? So let me scoochie over. And so when I look at all my, when I look at all of my potential answers, this won't add up to 8. This won't add up to 8. This won't add up to 8. This won't add up to 8, but it does have a difference of 8. So that's why that's my winner. Very good. So we got x plus 12 and x minus 4. Someone in the chat already had that in there for me. That's awesome. So then it looks like this. Okay. Once it looks like this, you guys should be like, I know what to do. Anybody remember what to do here? What do we do here? Nope, we don't have to do the square for this one. This is the zero product property. Remember, it's because, yeah, very good. This times this equals to 0. So therefore, I'm going to set each thing equal to 0 and solve it. So the whole reason why we wanted this to be 0 here, remember I was sad because it didn't equal to 0. Now that it's equal to 0, I could set each of these equal to 0. So x plus 12 equals to 0. And x minus 4 equals to 0. Make sense? Let me sync because it's kind of slow right now. There it goes. Okay, so everybody okay with that? So then, yeah, now my answer is just x is equal to negative 12 and x equals to 4. So those are my 2 answers. Those are my 2 answers. Okay. But here's the thing. I don't want it to be equal to 0. I need to figure out what numbers would work. So now I got to figure out what to do with this less than symbol. So I'm going to show you how I do this. Okay. So the way I do this, there's several different ways to do this. And so I want to make sure everybody sees which way I'm doing this. So here's negative 12 and here's that 4. Remember that 4 that, oh man, hold on a second. It's not catching up. Give me a second. Okay. So what I use is a number line. Okay. So I already know this 4. Remember from this 4 from earlier? This is that 4 from earlier. Do you guys remember this 4 from earlier? Remember when someone said like, hey, I can use 4. And then we plugged it in and we're like, 48 isn't less than 48. But it was pretty interesting because that was the exact like border point. So we already know that 4 doesn't work. So do you guys remember back in like, I don't know, 7th grade when you learned inequalities, you would use these open circles. Do you remember that? And the reason why we're using open circles is because it's less than, not less than or equal to. Do you guys remember this? Kind of. Okay. So now I need to figure out what numbers would work. Now, someone said this earlier. So anything less than 4. Oh, it's okay. The open circle just means it's not a solution, but the guy right next to it is. So do you remember how earlier someone said, so anything less than 4? And I kind of said, well, yeah, kind of, right? So, or I said yes. So the answer is kind of yes, but not really. So I'm going to show you. So less than 4 worked. So all of these numbers in here worked, right? We already checked this. We already checked 3 and we already checked 2. So I know that all of these numbers here work, right? So then you did this like squiggly line. Do you remember that? So then I get to this negative 12, right? And I want to say, I wonder if the number, like the negative numbers would work for that too. Okay, so can you do me a favor? Can you plug in, say like -1? Can you plug in -1 and see if it's a solution to this inequality? Can you plug in -1 and see if it's a solution to this inequality? Awesome. All right, you guys are already giving me answers in the chat, so it means you're done. Okay, so I'm going to try -1. If you did not know how to plug in, no worries. I'm going to plug in with you right now. So I'm going to plug in -1 over here. So I'm going to try -1 times -1 plus 8. I'm asking, is that less than 48? That's what I'm asking. Everybody okay with that? So then I get, okay, well, -1 times, let's see, 7. And this is -7. Is -7 less than 48? This is a question. Is -7 less than 48? And everyone's like, yes, it is. So that's a solution too. So I'm going to color all the way until I get to -12. So these are all the solutions here. I also want to check the numbers out here, which we already checked, right? Did you guys check a number out here? Like, I don't know, did you try 10? Would 10 work for this? Let's see, 10 times 18. Is 10 times 18 less than 48? Is 10 times 18 less than 48? No. So this is not a solution area. That is not a solution area. I'm also going to try some negative number. I'm going to go with -100. You guys are like, Ms. Johnson, why -100? This number line is not drawn to scale. So don't judge me. Or judge me. That's fine. Judge me. There you go. Okay. So I want you to plug in -100. Would that work? Is -100 times -92. Wait, I need to write this down. Is -100 times -92, what is that? 9200? Is that less than 48? This is a question. Yeah, no, it's greater. So this one again is like, no. So this again is not a solution area. So any number between -12 and 4 is a solution to this guy here. So the way we write this is we go like this. We go -12, we go 4, we put X in the middle, and we do these symbols here. So this in normal people language, I'm going to type this out. Any number less than 4 and greater than -12. Okay, so this is actually how you would like speak it out loud, right? Everybody okay with that? So the reason why I want you to be able to say it is because people will read this from left to right, and you don't really read it from left to right. You read it from center out. So I'm thinking about any number that's less than 4, but also greater than -12. Okay. So this is the answer that goes here. So all of this answer right here goes over here as the answer for this. Okay. I want to bring it back to this problem right here though. Would you say that they can use any number that's less than 4 and greater than -12? Would you say any number less than 4, greater than -12 for the answer for number 5? Is that what you would say? So remind yourself what X actually means. So X means the width of the rectangle. Okay. So it's the width of the rectangle. Like, so say for example, can I put -1 as the width of this rectangle? Can I put -1 as the width of this rectangle? Yeah, you cannot. Yeah, you can't use -1 as a length of a rectangle. That's like me saying like, hey, and I used to say this when we worked at the school, and there was an actual donut shop, half a block away. I can't, yeah, it doesn't make sense in the real world, right? I can't say like, hey, Nathan, can you run negative half a block and get us all donuts? That doesn't make sense. Right. So yeah. And so when you said the answer is anything less than 4, that's why it was like a yes-ish answer, because not really anything. Like you don't want to use negative numbers, but I understood what you meant. So that's why I said yes. Okay, so do you see the difference between this answer here? So what would the answer here be? It would be, let's say, I would say anything from here. So here's my real answer for this. It would be 0 less than or equal, not equal to, sorry, x less than 4. Ms. Johnson, why would you cut it off at 0 for this? Because I can't build you a rectangle with negative side lengths. Does that make sense? I can't build you a rectangle with negative side lengths. Exactly, right? So why would this answer work here, but this answer work here? Because this answer has no context, right? This is a straight equation. And so negative 12 exists on my number line. So it's fine. So, okay, so I showed you with a graph. This is my graph here. And I wanted to show you one more time with a graph though. Okay, so I want to show you using Desmos this because I think it's pretty cool. Plus, you guys know how much I love Desmos. For those of you who are new to our class, I usually call Desmos. Anybody, what do I call Desmos? Yes. Someone asked a really good question in the chat. I believe that right there. Hey guys, what do I call Desmos? This guy right here. Oops. Yeah, Desmos, I usually call Desmos my best friend, and I think they think it's funny, but it helps because Desmos helps me so much. That's why I call it my best friend. Okay, so here's the equation. I mean, the parabola x plus 8, right? X times x plus 8. I'm also going to graph the line y equals to 48. Y equals 48. And it doesn't look like it's anywhere except for if you get to 48, it's up there. Do you guys all see this? So I want to know when is, now listen to me say this. When is x plus 8, the red guy, when is the red guy less than the blue guy? When is the red guy less than the blue guy? Okay, when is the red guy less than the blue guy? So when I say less than, I mean lower than. Do you see that in this picture? Do you see when the red guy is, exactly. When the red guy is less than the blue guy. And you guys are like, yeah, all of this time, Miss Johnson, this whole time. Yes. And when we talk about when, we always talk in terms of X. That's why our X is that's why our X is in the answer. So literally this says it's less than it from, below the blue line. Someone said that so well. Let me clip this. Oh, I should probably clip this whole thing. Otherwise, this is not going to make sense in context. Let me go like this, and then maybe go over here so I don't have to clip so much. All right, let's go like this. Where'd my little guy go? So copy. Tell them to be a little bit quieter. Is that okay? Okay, so if I copy my picture over here, right, make it a little tad bit smaller so it's not gigantic-ish, right? It's literally when you guys said, someone said this really well, below the blue line. So when is this true? So copy right here. So below the blue line. So when I'm using, here it is. When I'm trying to solve the equation, x plus 8 is less than 48. I'm looking on this graph for when the red parabola is below the blue line. So Ms. Johnson, you're saying all of this is my answer? Right? Yeah, all of that is my answer. This whole part of the parabola here, sorry, it's catching up. Right? This whole part is my answer. But in reality, we just look at the X. So we just want to look at X from left to right. So it looks like it's right there. to right there. And so if I cast that all the way down, it's from right here to right here. You guys all see that? From right there to right there. And if you look at those numbers, and I'll bring back Desmos again, just so you can look at these numbers. Is it a surprise to you that it's negative 12 there? Is it a surprise to you that it's 4 right there? So it's all the numbers in between negative 12 to 4. Does that make sense? So one of the things that I hope that you get out of this class is understanding like why the picture matches the answer, which matches the words, which matches your equations or your inequalities. That's what I would really like. Because if you can make all these connections between these things, that's the important thing. You graphing this on a graphing calculator, punching things in, that's not you doing math. That's you punching buttons, right? But once you get the like the graph and you can interpret it and be like, oh, it's from here to here, Miss Johnson. And that's the important part. That's the big deal part. Okay. All right. So the next thing that we're going to do. So we did all that. Any questions on any of this? Connecting all that together? No? Very good. Very, very good.